Imagine you're flying 35,000 feet above the Earth. Outside your window, the temperature is colder than Antarctica. The air is so thin that you couldn't survive for more than a few moments, and separating you from that deadly environment is a tiny plastic window. But if you look closely, you'll notice something strange. There's a tiny hole in it, a deliberate hole, in an airplane, thousands of feet in the air. At first glance, that sounds like the last thing engineers would ever want. So why is it there? And how can something smaller than a grain of rice help protect millions of passengers every year? The answer involves crushing pressure, early aviation disasters, and one of the smartest safety features hiding in plain sight. Every time an airplane takes off, a battle begins. Not between pilots and bad weather, not between engines and gravity, but between air and pressure. At sea level, the atmosphere presses against us from every direction. We don't notice it, because our bodies are used to it. But as an airplane climbs higher and higher, something strange happens. The air outside becomes thinner, much thinner. By the time a jet reaches cruising altitude, the outside air pressure has dropped dramatically. If the cabin pressure dropped too, passengers would quickly lose consciousness. So engineers do something remarkable. They create an artificial atmosphere inside the aircraft. The cabin is pressurized to feel much closer to conditions on the ground, comfortable for passengers, but stressful for the airplane, because now the pressure inside is trying to escape, and every surface of the aircraft must hold it back, especially the windows. Airplanes didn't always fly at 35,000 feet. In the early days of aviation, most aircraft stayed relatively low. Pilots could simply open a window and feel the wind rushing by. There was no need for complicated pressurization systems, no need for special window designs, and certainly no need for tiny holes. But as aircraft improved, airlines wanted to fly higher. Higher altitudes meant smoother flights, less weather, and greater fuel efficiency. There was just one problem. Humans aren't designed to live that high above the Earth. The higher airplanes climbed, the more engineers had to rely on pressurized cabins. Suddenly, aircraft weren't just flying through the atmosphere. They were carrying their own atmosphere with them. And that created an entirely new engineering challenge. Every flight was now turning the aircraft into a giant pressure vessel, like an enormous soda can, one that expanded and contracted over and over again, flight after flight. Day after day, year after year. Most of the time, passengers never noticed, but engineers did, because every takeoff and landing placed stress on the aircraft's structure, including one surprisingly vulnerable area, the windows. And in the 1950s, the world learned just how dangerous that problem could become. In the early 1950s, a revolutionary airplane entered service. It was called the Comet, the world's first commercial jet airliner. Compared to older aircraft, it was faster, quieter, and capable of flying higher than ever before. It seemed like the future of air travel had arrived, but then something terrifying began to happen. Several Comet aircraft suddenly broke apart in midair. Without warning, passengers and crews had no chance to escape. The aviation world was shocked. How could a modern aircraft simply fall apart? Investigators spent months searching for answers. At first, nobody knew what had gone wrong. Then, engineers began reconstructing the accidents piece by piece. What they discovered changed aircraft design forever. The repeated cycles of pressurization were slowly weakening parts of the aircraft. Tiny cracks were forming, and many of those cracks began near the windows. At the time, the Comet used large square windows. The sharp corners concentrated stress. Over thousands of flights, microscopic cracks grew larger, until eventually, the metal could no longer withstand the pressure. The lesson was painful, but it transformed aviation. Future aircraft would use stronger designs, rounded windows, better materials, and far more sophisticated engineering, including improvements to the windows themselves, improvements that would eventually lead to the tiny hole you see today. If you've made it this far, you're probably expecting the tiny hole to be part of a single window. But here's the twist. The window you're looking through isn't actually one window at all. It's three. Every time you sit next to an airplane window, you're looking through multiple layers of transparent acrylic. Each layer has a different job. The outer pane is the workhorse. It's the strongest layer in the system. Its job is to face the brutal conditions outside the aircraft. freezing temperatures, powerful pressure differences, and constant stress during every flight. Behind it sits a second layer, the middle pane. This layer acts as a backup. If something ever happened to the outer pane, the middle layer would provide additional protection. Then there's the pane closest to you, the inner pane. Surprisingly, this layer isn't there to hold back pressure. Its main purpose is to protect the other layers from curious fingers, accidental scratches, and everyday wear inside the cabin. So if there are 3 layers, which one contains the tiny hole? The answer is the middle pane, and that's where the real magic happens. Engineers have a name for the tiny hole. They call it a bleed hole, and despite its tiny size, it performs a remarkably important job. To understand why, imagine what would happen if the hole didn't exist. Remember the pressure difference between the inside and outside of the aircraft. That force is constantly pushing against the windows. Without the bleed hole, pressure could become trapped between the layers. Multiple panes would end up sharing the load in unpredictable ways. That's not what engineers want. They prefer something much smarter. The bleed hole allows air to move between the cabin and the space between the inner and middle panes. As a result, the pressure in that area stays nearly the same as the cabin. That means the outer pane ends up carrying almost all of the pressure difference, exactly as designed, exactly where engineers want the stress to go. In other words, the tiny hole acts like a traffic controller for pressure, directing enormous forces to the strongest part of the window. Every flight, every day, all around the world, millions of passengers trust their safety to a hole that's smaller than most people even notice. As if managing pressure wasn't enough, the tiny hole has another job. Imagine breathing onto a cold mirror. Almost instantly, fog appears. That's condensation. And the same thing could happen inside airplane windows. Without proper airflow, moisture could become trapped between the layers. Over time, the window could become cloudy. Passengers might struggle to enjoy the view. The bleed hole helps prevent that. It allows moisture to escape and helps keep the window clear, which means every breathtaking sunrise, every glowing sunset, and every view of the world from above the clouds is a little clearer because of a tiny engineering detail most passengers never notice. At the beginning of this video, we asked a simple question: why would engineers put a hole in an airplane window? At first, it sounds completely backward. After all, airplanes are designed to keep the outside world out, the freezing temperatures, the thin air, the crushing pressure differences. So intentionally adding a hole seems like the last thing anyone would do. But that's exactly what makes great engineering so fascinating. The best solutions aren't always bigger. They aren't always more complicated. Sometimes they're surprisingly small. That tiny hole helps control pressure, protects the strongest part of the window, reduces moisture, keeps your view clear, and quietly does its job on every single flight, thousands of feet above the earth. Most passengers never notice it. Most never think about it. Yet every time you look out an airplane window, it's there, working silently in the background. A tiny reminder that modern air travel isn't held together by one giant invention. It's held together by thousands of clever ideas, small details, carefully designed solutions, and sometimes one tiny hole. So the next time you're sitting by the window on a flight, take a closer look. You'll spot it almost immediately. And when you do, you'll know that one of the smartest safety features on the airplane has been hiding in plain sight the entire time.